Hi, everyone, and thanks for joining the Data Legends podcast today. I'm so excited to welcome back our guest, Wes Gelpi, an analytics leader at SAS, who we spoke several weeks ago and talked about all sorts of different analytics, infrastructure, data type challenges facing large enterprises today. And we talked about how you lead teams in an environment like this. And today we're going to dial a little bit more closely into the data lake, the data warehouse, data virtualization layers. What does it all mean? And what is the role for each of these really significant types of innovation within an enterprise? Because at the end of the day, how do we help derive better outcomes and better answers by using technologies like those that we'll discover today? So welcome, Wes. Thanks for being here.
Thank you. I'm very glad to be back.
Awesome. Well, so why don't we kick it off? I think, our listeners probably got a little bit of perspective last time when we talked a little bit about your role and experience, but maybe as you start to think about, what each of these technologies look like, the lake, the warehouse, and a virtualization layer, remind the audience of your background and your frame of reference as you talk through this. But maybe we'll start with the lake. Like you think about an enterprise data team needing to provide better answers, constant answers to the business. How do you see each of these technologies really playing a part?
Yeah, certainly. So briefly, I've led teams in the data engineering, data science, and analytics, and also the cloud and infrastructure engineering group. So I've seen this problem addressed and encountered from several different ways. I think we talked a little bit about specialization last time, and I would say it also comes into play here within the architecture space specifically. My ideal architecture, maybe to get a little bit to the punchline, does have a mixture of all of these different components because it depends on the data that you're working with. It depends on the speed in which you need the data, who you're working with in terms of consumers as well as developers of the data. So all those come into play. So my ideal architecture does have components of storage and compute and access or virtualization all split out into separate modules, so you can scale one independently if you need to.
It's we hear sometimes with our customers, they want to have that autonomy, right? How do I scale up storage as I need? How do I scale my resources for compute as I need? How do I then scale up my application to support that? How do you really do that? Like maybe we'll dive into the lake versus the lake house in your
Yeah.
environment. What do you count on? What do you think about when you think about how the lake is most useful and how the warehouse is most useful?
Yeah, certainly. So first of all, I think that it's very important to get three letters in the right order for me, and that is ELT as opposed to ETL. We are no longer in the area where we need to be budget conscious when it comes to storage, especially with the advent of the lake. Like, we can store as much data as we need, and we should be more focused on what are their data retention policies and how do we strategically store that data either in cold storage or hot storage. So extract, load, and then do your transformations after you've gotten your data into the lake. So that's a key, I think, value proposition for the lake is we just have a place to store all of that. Now, from there, the possibilities tend to maybe become a little more endless, as they say. Sometimes you need to be able to have data in a structured format before you're pushing it out. Or let's call this maybe one of your data products. And there's a very valid use case at that point in time to have your data in a more structured format for either an application to consume or an analyst to do further work with it or to put it onto a chart or a graph. And so at that point in time, a data warehouse is where you can see a lot of value. Now, again, this is where specialization and going different ways with things can vary. But then you also have the possibility of either storing this data as a structured physical table, or you can virtualize that data in something that I call data virtualization. I'm not coining the phrase, but that's what I'm referring to, where you can now develop views of data while still keeping it stored physically in your lake. So this allows for that scaling, as we were talking about, or that modular component where you may have some very compute intensive queries that need to run. Well, you don't have to scale out your storage or your lake to achieve that. Conversely, you may need to store a lot of data, but you don't need a whole lot of compute to deliver that. Then just scale out your lake even further. But each component plays a critical role in this that we cannot discount and just try to like go all in on one area or another.
Yeah, no, it makes a lot of sense. I'm wondering how your vision plays out in an on-prem environment where you have sort of like on-prem storage or some type of hybrid storage, and then compute that you have control over and your apps versus a cloud-based environment where, one of the beauties we think of a cloud-based environment is you have a little bit more room to sort of scale up or scale down on demand, and you're not the person having to procure these things months and years in advance. Does this philosophy play in both of those environments for you?
It does to a degree, but obviously the cloud infrastructure and construct makes this a lot easier to do. If you want to, you can take some on-prem servers and make your own private cloud, as they say, and make your own private instances of this. But the public cloud is really ideal for this. Now, what is very important though is that you spend a lot of time and kind of thought power, brain power up front in terms of automation. You mentioned scaling up and scaling down, and that's something that you want to be able to put in place from the very beginning. You don't want to be sitting there later and trying to think, well, is this where we automate? Is that where we automate? That should be a foundation. And tying back to giving engineers time to create and think about this, you should be prepared to have kind of that slow ramp up when it comes to delivery on your initial infrastructure. You want to give engineers time to think through it in that cloud environment, because there are some things, like security, that are both extremely important, but also in some cases can only be done at the beginning and cannot be redone. So I think the cloud is primed for this, but you still have to give a lot of thought into it.
Yeah, no, I mean, certainly we see, and I do think by virtue of where organizations are at today, right? When we can take advantage of the cloud for services like this, there are definitely some real benefits. So it's good to know that it applies for both. Let me ask you another question about the virtualization layer. So sometimes at Chaos Search, we hear our customers talking about the impact of data movement, right? So how activating out of their lake is sometimes hard because you're moving the data out of its stored environment, you're putting it into the lake. So not unlike what you're talking about when you talk about ELT. And then should you want to analyze that in a warehouse-like environment, one might assume there's some sort of pipeline creation or extraction that has to come for that to happen. How does the virtualization layer play a part in making access between those things, the warehouse or the lake, more accessible?
So the virtualization layer is kind of in my opinion, maybe the secret, not so secret weapon of modern day infrastructure. So remember, we're breaking things apart. So virtualization is all compute, and there are some technologies out there that will do storage as well as compute, and others that are just focused on compute. Why it's important is you have all of your data stored in a data lake or maybe a data warehouse for a specific reason. And now you can create almost infinite views of that data in the virtualization space for your individual users to build custom views without having to change or replicate your physical data. So now you give users the ability to kind of dream up their own use case, follow paths, but also not having to rebuild your underlying data. So that's extremely important. The data virtualization layer also allows you to have your data wherever you need it. So there might be some data that you physically do not want to or cannot move. And so long as you're storing it in a technology where you have a valuable connector with that virtualization layer, you can keep it there. One important part of virtualization, as opposed to maybe an API to your database, is that it's separating the compute. So it's not driving the compute requirement to your database that may risk that database serving other purposes that are more maybe real-time operational. And then another component of this virtualization layer that is really very much a value add is that it is a place where you can provide that authentication, authorization component, and you can define things like role-based access to your data. So now you and I could log into the same exact virtualization environment, and because of the roles that we have, automatically we get different views of data. We have some columns that are obfuscated. because it's applying role-based security and not physical security.
So that goes to, that's helpful. I was thinking a little bit about the end user, right? So the people on a team who are saying, how do I get this information? And you just talked about some of the RBAC controls that allow people to see what they should see. And do you think in a scenario like this, by doing something like that through this virtualization layer, you are kind of minimizing risk, right? And making the right data available to the right users. So maybe the bigger question is, are you able to minimize complexity in a model like this so that no matter the user, they can go in and get the answers they want?
You definitely minimize the level of complexity that your support team, your operations team have to worry about. They're no longer having to worry about, well, I need to build a view of data that meets every single possible scenario that I can think of. And if a user comes to me and says, hey, I need this data structure, this data view, now they are stuck in a place where they have to do that view as well. And maybe they have to find a place to store it and apply security to it. Now you're federating how the different users can access the data. So you may have a power user who understands the basics about SQL. You can give him or her an access to this, and they can make their own views of the data while you're still controlling the physical data. You still can control what data elements they have access to or what they have obfuscated, because you have that core central. So you're able to have centralized your physical data while federating out the different views of the data to your power users.
That makes sense. What do you think about, even from a cost management perspective? I mean, we're constantly dealing with, I mean, I think back to our own customer conversations, organizations who are wanting to provide users more access to better data, but you're constantly working within the constraints of, like, how much data do you really want to put in your lake? How much data do you really want to put in your warehouse? And then beyond that, how much of that data do you want to make available in an always on manner for purposes of analytics? So in a model like this, do you see that there's an element of sort of cost consolidation?
There certainly can be, but it requires a lot of forethought and consideration. The cost element is always going to be there. You're always going to be paying money for the cloud. But what you have to do is set aside real time to say, you know what? Do we really need this data accessible every single day or every single minute? Or can we shift it to a colder version of storage because we really need it every so often, or at this point in time, it's archival. You need to be able to set up automation practices in place to enable that cost control. Now, on the compute side, this is where you need to enable, really lean in hard on automation, but also that scale up and, more importantly, scale down approach to things. Obviously, compute's where your cost is these days, but you can still control it by making sure that you have proper auto scaling groups in place.
Yeah, no, we definitely hear a lot about that in our side of this world too. At Cancer, we're big believers in the separation of storage and compute for this purpose. And there's all sorts of different solves out there, but there's merit into having not be locked into multiple elements when you're trying to drive efficiency within the operation. So
Absolutely.
where do you see this? So when you hear, the market talking about things like a data mesh or a data fabric, and you think about a model like this where you're serving structured and unstructured workloads quite well, you're getting access to the information that you need. Where do you see the role for something that is a mesh or a fabric, or do you?
Yeah, I I struggle with some of those terms, to be quite honest. To me, there are core components, and there definitely has been innovation and differentiation in data storage and data analytics as of recently, in the past several years. But to me, it's still these core concepts of you don't want to have your analytical queries and your analysts and your data scientists hitting your production database. So you still, I mean, for 9 out of 10 use cases, you're going to want to move that data somewhere. It's a great. I mean, the data virtualization vendors out there, they do push more of that mesh concept, and I think there can be a value to that. Don't get me wrong, but when you're really talking about wanting to create a differentiating piece of analytics or differentiating piece of data, you want to make sure that you're treating that like a piece of software And you don't want to start having your operational data stores being required to serve up this, this different piece of data for analytical purposes that is a differentiator. You want to make sure that you're able to specialize your data analytics the same way you specialize your operational workloads.
Yeah, no, it makes a lot of sense. Do you think, I guess my question is, what would you say to an organization who's under pressure to say, oh, I don't need my warehouse anymore. I'm going lakehouse, or I'm going to use my lake and deploy something else. What would you tell them to think about from a considerations perspective about the importance of each of these elements as they sit today?
To me, it really comes down to what use cases are you trying to deliver, and why do you need to move to a different strategy or a different model? These endeavors are not without impact to groups. They're not without slowdown. No matter how much there is of a promise of speed on the back end, you are going to be impacting teams for potentially years to come. And so I think that you have to be very clear on the why you would be looking to change your model. Now, obviously, I think we can all agree that some of these elements are core and required. If you're very early on in your journey, then I may say, well, yeah, of course you need a data lake, and of course you need these components. But if you already have a functioning data lake with core components to it, I would be a much bigger proponent of figuring out what feature you are missing, you feel like you're missing, and addressing that specifically more than ripping up everything and trying to go a new direction. This is moving the Titanic, if you will. This is not moving a Ferrari sports car.
Right. There's a lot of potential downstream impact of changes like that. Absolutely.
Yes.
Well, Wes, we really appreciate your perspective. I mean, there's just no shortage of questions when it comes to the role of each of these elements, given how just incredibly noisy this overall data management space is at the moment, but also how much innovation there continues to be in the space, right? So trying to stay true to what do I know is working, and what are the models that I sort of tried in my business that work, and how do you continue to, as I'm hearing you say, drive better outcomes from them and figure out how to make them, continue to produce, so that, I think you called it, the data products are something that's valuable.
Yes. Absolutely. I think one thing that we have to really start thinking about, and arguably most companies probably already have to a degree, but we need to be treating our data engineering and our data science as we would a software product. We need to be really looking at this as something that we have to manage. We want to be sure that we can have source control over the code that we are developing here. These are very differentiating assets now. It's not just a research project, and so we need to treat it the same way we would treat, changing the direction of a software engineering organization. These data scientists and data engineers are developing software, so we need to make sure that we are, treating them accordingly.
Yeah, I mean, there's a real win in that model to think about that the outputs are much more tangible than they used to be. Like benchmarks towards some other milestone. The reality is, in today's model, the output are products, small, a whole series of, small or large data products that can be placed into any, multiple different sorts of functions in order to derive an outcome. So it's nice to see that, but the incumbent then is like, on people managing an environment like this, you have to treat it this way. They're not just for exploration. We're not spinning up data science teams who are spending their days exploring, potential solves. They're building solves.
Yes, you don't want a core piece of code that helps decision whether or not a customer gets routed to this sales team or that sales team sitting on somebody's laptop, right? Yeah. You want that control somewhere when you have the potential to make a sale or to impact a customer experience, which data science projects do every single day. You want that to be treated like a very hardened piece of code.
Yeah, and really give it its due.
Yes.
Well, it doesn't raise any small set of challenges for anybody's data team, but the opportunity is significant.
Absolutely.
Awesome. Well, thanks for joining us today, Wes. What a great session. So for our listeners, if this is the first session you're joining, feel free to listen to part 1. And Wes, we look forward to continued conversations. Thank you for your time today.
Thank you, Courtney. It's been a pleasure.